thank you very much. So as mentioned, I'm a PhD student. I will be graduating sometime within the next year or so. My research has been all about co-digestion. And so we'll be talking today a little bit about selection of feedstocks. We'll talk just briefly about what co-digestion is. We've already kind of hit on that topic a few different times today already, but I'll go into a few of the practical aspects of what you might be looking for if you're interested in digesting something other than manure or in addition to your manure in a digester. So first of all, what is co-digestion? Very briefly, because we have actually had on our webinar series, if you've been following along with the last two in our webinar series, Chad gave a really excellent overview of what co-digestion is. I also talked a little bit about not just what co-digestion is, but some of how we test that as researchers, how we look at what the actual impacts of co-digestion are. Again, if you're interested in those, the recordings of both of those presentations are on our website. So I encourage you to check that out if you didn't get a chance previously. Okay, so again, just briefly, why use co-digestion? I've gotten this question quite a bit, actually. People are like, if you can do it with manure, why not just do it with manure? That is true, although as Dr. Lau already pointed out, depending on the size of the farm, depending on other factors, sometimes economically, it's just really tough for a farmer to make it work on manure only. From an industrial standpoint, first of all, some feedstocks are just not really good to be digested by themselves. They just won't work in terms of anaerobic digestion alone, or they're not being produced at large enough volumes for that to really make economic sense as well. So co-digestion gives a couple different advantages from the agricultural standpoint, the farmer standpoint. You can bring in a lot of money on tipping fees, as Dr. Lau pointed out earlier. Also, bringing in additional energy production, that can be a huge game changer as well. From the standpoint of being able to, yeah. So yes. So it is a contractual thing that the parties set up at the beginning, and what exactly that will look like is going to be very dependent on the arrangement between both parties. Manure is a very stable feedstock for anaerobic digestion. So from an industrial standpoint, that basis of having manure in a digester makes it a lot more technically feasible to do a lot of digestion that otherwise just wouldn't really make sense. So in terms of some other practical aspects, if this is something that you or someone is considering, how would you go about choosing a feedstock? How would you go about selecting a feedstock? And how do you predict gas production? So first of all, in terms of what kinds of parameters you might want to test, this is definitely not comprehensive, but here's a few different things that we look at in particular as researchers, and that might be appropriate as well to look at if you're considering co-digestion. In terms of feedstock composition, what actually is in the feedstock in the first place, I'll go through each of these in a little bit more detail, but you definitely want to know a lot of information about your feedstock and the variability of that feedstock. Is that company going to be giving you the same thing every single time, or is it going to be very variable depending on the month, depending on the day even. That is all important to know. Gas production, both not just how much gas or how much methane is being produced, but also how fast it's being produced. With manure, it's most of the time pretty predictable. With some of these other feedstocks, as I'll show a little bit later, it can be very different. And so being aware of what you're, at least generally, what kinds of things you might be getting out of a feedstock, it's important to be aware of. And then in terms of digester balance, you're going to want to know, if you have a digester already, hypothetically, you're going to want to be very aware of if your digester already has everything it needs, or if it's out of balance in some way. If it has everything it needs, you definitely do not want to get it out of balance in some way. And so maintaining that balance is important. So in a little bit more detail with each of these, carbon and nitrogen ratio, those of you familiar with digestion are already pretty familiar with this 30-to-1 carbon and nitrogen ratio. That's pretty standard. There is a little bit of a range there, but generally that's kind of what you're going to want to be looking for, again, overall for all of your feedstocks. So you might have something that's a bit higher in carbon or a bit higher in nitrogen, and that's not necessarily a bad thing, just as long as you've got balance somewhere else. Similar with carbohydrates, proteins, and lipids. Lipids or fats. I don't necessarily have strict numbers on that. There's ongoing research on, what's kind of ideal, but in general, you don't want any of those things to be too extreme, again, on the whole, with all of the feedstocks going into your digester. Both chemical oxygen demand and total and volatile solids, I'm going to be a little bit more vague on as well. Partly because it's going to depend a lot on your digester type. Some digesters type, like some digester types, like plug flow digesters, for example, handle very different things than a mixed tank digester can handle, in terms of, what your ideal residence time is, what your ideal solids loading is. So that is going to be pretty dependent on digester type and your existing digester capacity. But just being aware of what you can do and what you already have is important there. So then going back to gas production, both in terms of how much methane that you are producing and how fast you're producing it. One of the things I wanted to highlight here is it's going to be really important to be aware of what your system can handle. That's also come up a couple of different times today. Carl's presentation earlier and Dr. Mee's presentation. If your system has already been built larger and can handle additional capacity, which is maybe one of the reasons you're even thinking about co-digestion in the first place, that's great. But producing more gas or producing it faster might not necessarily be ideal if your system is not built for it. You could cause a lot more problems than the benefit you gain from it. And just again, going back to digester balance, you have a digester, or if you already know, I want to do co-digestion and this is how much manure I have. You don't necessarily have to be spot on all of these. In fact, probably won't be spot on all of these for specific feedstocks. You want to make sure that total what's generally going into your digester is in those ranges overall. So how do we test these parameters? For most people, I would recommend just going ahead, sending it to some kind of lab. Of course, it's going to take time and it's going to cost money, but the alternative is testing it on your own. Which in some cases that might make a lot of sense, but for most people, the upfront costs to get the equipment and then the employee time and expertise and stuff like that is going to end up not being as beneficial as just sending it to someone else. But of course, there might be some situations where that could be could make sense. One thing, so the next several slides that I'll be talking through is just kind of peeling back the curtain a little bit, you know, since probably most people watching this presentation online or here won't ever be doing this stuff. This isn't necessarily supposed to be like an instruction manual, more to peel back the curtain a little bit and say, so what happens? Like, what are we doing? What are we doing in those universities, or what are the labs doing when you send your sample off? Why is this data coming back the way it is, or how are people even testing it in the first place? So for carbon and nitrogen content and chemical oxygen demand, at least this is what we do in our lab. We have some kits. We've actually got some examples back there. We work with the kits from a company called Hack. They are super easy to learn. I train my undergraduate research assistants on them all the time. Pretty straightforward, some upfront costs to get the spectrometer equipment and so forth, but then pretty easy to learn. Carbohydrate, protein, and lipids, there are actually a lot of different methods out there. The ones that I've got listed on the screen are, again, the ones that we use in our lab. But there are some alternative methods. As far as I've found, there aren't just simple, straightforward kits for these to use, or at least not quite as straightforward and simple as some of those more common ones. But there is a growing amount of research that's being done that's indicating that that knowing some of this information could be useful. And again, total and volatile solids, it's probably a lot more familiar to many people. It's stuff like a drying oven, a furnace, and a really good scale are all important aspects of that. So in terms of testing gas production, we've got a little demo set up in the back. There's not necessarily that much to see on a daily on an hourly basis per se, but I thought it might be useful to actually have a setup of what we do in our labs so that you can look at it. And I'll just walk through very briefly how we go through this. You're going to be testing any kind of feedstocks. You at least want monodigestion, which would be an inoculum and a feedstock, one single feedstock. So an inoculum, it could usually we just use digestate from an existing digester. We're working very closely with Biotown, and so they All right, great, thank you. Okay, so just kind of on as a baseline, gonna need to test just the feedstock by itself. And then in terms of adding in some additional feedstocks, it can be really useful to see how does it change when you add more than one thing. And I'll show some data for that in a minute. Again, I've got some demos in the back just so that you can kind of visualize a little bit more clearly what kinds of things we're talking about. It's to get really good data for this, you're going to need at least 30 days for one of these. Often I end up running mine more like 40 days. That's part of the reason that if you hypothetically were to send this to a lab to get this analyzed, it's going to take a while. It's because it takes that long. You know, if you think about your residence, a typical residence time in a digester being around 28 to 35 days or so, depending on the digester type. Well, it's the same thing here. It'll take that long for us to get a really good sense for how much the gas those things are actually producing. And so got some of this equipment in the back as well that you can look at. We do both volumetric measurements. We just use a syringe pretty much to measure gas volume. And then gas composition is going to be really important. With manure, seeing 60% methane is really typical, or roughly in that range. But with a lot of other feedstocks, that's not necessarily the case. So being able to know gas composition is really important. Early on, especially for the stuff I usually work with, even twice a day for like the first day or two, and then daily for about a week, and then measure every couple of days after that. Gives us some pretty good data. Okay, so one of the things I wanted to point out with some of this actual data, we've got these, we've got 5 different feedstocks plus inoculum up here, and 3 different experiments for each of these. Obviously, you can tell there's a lot of different variability between different feedstocks. This manure is kind of your very typical biomethane production curve. Most of it goes up within about the first 7 to 14 days, and then you're still getting some up through about 30 days or so. But then some of these other feedstocks, you might end up with quite long lag phases. These ones generally have a lot of lipids in them, which is part of the reason that you're seeing those lag phases. Or the starch, overall, it didn't produce a lot of gas, but it produced a lot of, well, all of the gas it produced. It's a little bit hard to see since the scale is comparable to the others, but it would produce gas very, very quickly. The other thing I wanted to highlight is that between experiments, we would sometimes get a great deal of variability, which often means that there's some kind of variability in the feedstocks themselves. They're not actually sending the same thing every single day, which is maybe not necessarily super surprising, but that's something that you'd want to be aware of if you're considering co-digestion. So just kind of talking through gas measurements again, and like what you would actually be looking at. When we do these tests, we measure yield, which is not just, you know, actual methane produced, but it's methane produced per amount of stuff added. So any number that I report is going to be methane produced per grams of volatile solids added. And so part of the reason I emphasize that is because when you're talking about co-digestion for yield, what you're actually looking for is basically a weighted average, which will come out somewhere in between. Because yes, you are going to get more gas, but you're not going to get more gas per amount of stuff added. So yes, you do get more gas as you put more stuff in, which is great. But in terms of what you're looking at for yield, what your yield that you're looking at, your additive prediction, which is pretty typical, is going to be somewhere in the middle. Sometimes you can see synergy, and this is kind of a simplified version again, but again, sometimes you can get more than 1 + 1 = 2. Sometimes you can get 1 + 1 = 3, which is cool. Or you can get it faster, which is what I will show with some actual data here. Here we've got our manure and our starch, and so what you would expect to see. These are 2 different ratios. We've got 2 different experiments or 2 different treatments running here. This is one ratio. This is the other ratio. That's what we would predict to see based on just knowing what we have, knowing what we put in. What we actually got for one of the ratios was way better. So that would be a huge example of, yes, we are definitely seeing some synergy in this. This other ratio, there's a lot more variability with these three digesters, 3 replicates that we were using. So not necessarily, can't necessarily say we're seeing synergy overall, but you can pretty confidently say that it was at least additive. One thing, going back to you can get it faster. You look here, we are pretty much, all of the treatments are above what we would have predicted in this early phase. So is that always better? Well, that depends on if your system is ready. So that could be really good, you know, if you have additional capacity, if your infrastructure is all built up for that, if your electricity and RNG agreements or whatever else is all set up, that's fantastic. If you're not, then it's a lot worse than if I overfill one of these 5-liter gas bags in 12 hours. If I overfill one of these, it's really messy and unpleasant to clean up. If a full-scale digester has an issue like that, it's a lot messier to clean up. So hypothetically, if you're thinking about doing one of these, should you do mono or co-digestion? I would say yes. Definitely at least do mono digestion. That's going to give you a baseline. Co-digestion can tell you a lot more information, so that could definitely be useful information to have. But at minimum, you should have a mono digestion test. Some other considerations, just other things you might be thinking about in terms of co-digestion. If you're, you know, maybe looking at multiple and the actual practicalities of who do you go find to see if they need you to digest their waste and stuff. That's all an entirely different discussion. But in terms of, say now you found a bunch of different possible feedstocks and you're saying which of these, 1 or 2 or a couple of them maybe should we use. Here are a couple of other things to consider. If there would be any kind of additional pre-treatment needed, maybe grinding to get smaller particles or something like that, how frequently you get whatever feedstock it would be. You know, are you getting this every other week, or can you be getting this every day? Those kinds of things can be useful to know how much you're getting, of course. And foaming is, again, a whole nother presentation, at least all on its own. But being aware that foaming could cause an issue and being aware of whether or not that particular feedstock could cause a foaming issue, all of those things are important to be aware of as well. So for just some final takeaways here, co-digestion on the whole does generally increase gas production. Sometimes even better than you might have predicted. Although one thing that I do want to point out, just as kind of a caveat with these biomethane potential tests, since they are lab scale, there's all kinds of things that are different in a full scale digester. So, you know, it's not as simple as saying, okay, now we know this, we can scale it up to a full scale digester immediately. That's not necessarily what I'm saying, but at least it can give you an idea of what generally what those feedstocks are capable of, what you might end up seeing in a digester. Just kind of rough rules of thumb more than, you know, okay, now I can just multiply that by 1,000 and I've got my digester or whatever. There's lots of different ways of testing, and using lots of those ways to test those feedstocks is advisable. Know what's in your feedstocks, know what's in your digester already, and what your digester can handle. Mostly overall balance, stay in the ranges that are pretty well established of what you ought to be staying in overall again. And all of these things have variability in feedstocks. Getting feedstocks tested more than once, or maybe taking, you know, several samples over time out of a feedstock, so you can get a gauge for what kind of variability you're looking at. That could be very helpful as well. And And with that, I'd be happy to take questions. Again, got lots of videos on our website. These will be on our website as well once we get those posted.